Hello everyone, welcome to this tutorial. In today's class we're gonna see how to do limits at infinity, and we're gonna see some limit theorems, basically two theorems, and we'll do some examples, and finally we'll finish by giving exercise that you'll do it. At the end of the class everyone should be able to do the limits of such kind. So this is the expectation from this class. For now, let's gonna start. Okay, as introduction, if f of x gets closer to L as x increases without bound, then L is said to be the limit of f of x at x approaches to infinity. So when x approaches to infinity without bound, if f of x gets closer to L, basically we say that such kinds as horizontal asymptote. As an example, for example here, the limit as x approaches to infinity of a rational function here 3x plus 100 over x squared, so the degree of numerator is less than that of the denominator, and here the degree of denominator and the numerator both are x squared. So when they are equal, what happens? In the first case, since the denominators here, the denominator is x squared, so as x become larger and larger, this will vanish to 0, since here is x squared, so it grows faster than that of the denominator. Thus the whole system approaches to 0 as x approaches to infinity. But what if they are equal? Let's see. For the first one, since the denominator is greater degrees, then it vanishes to 0. And for second case, we will do some mathematics. Basically here we see only the coefficients of the higher. So 5x squared plus 5x plus 9 over here, we're gonna divide by the higher degree, so our higher degree is x squared, so let's divide both numerator and denominator by x squared. So when we divide it, it gives 5 plus 4x by x is cancelled, so 4 over x plus 9 over x squared, and this one will be 2 minus 6 over x plus 1 over x squared. So we can distribute these limits from the laws of limit. So the limits of 5, the constant is itself, and the limit of 4 over x as x approaches to infinity is 0, since 4 over x as x approaches to infinity, 4 over infinity, 4 over, for example, 1 million, it approaches to 0 as x and become larger and larger. The same here, 9 over x squared will be 0, here will be 0, here will be 0, so we left only 5 and 2, so 5 over 2. Basically, for irrational functions that have denominators and numerators equal, we see the coefficients of the higher degree, and we then divide the numerator's degree by denominator's degree. That's the way. So the limits at infinity will be this one. We call it most of the time horizontal asymptote. The second lesson we're gonna see in today's lesson is the first theorem. What is sin x over x as x approaches to 0? If we substitute it, then sin 0 will be 0 and x will be 0. Then what is the value of 0 over 0? 0 over 0 may be infinity or negative infinity. It could be 0. We don't know. So at x it is undefined. That means at 0 it is undefined. If we graph this sine x over x, it looks like this one. So when we approach from both left and from both right to 0, this limit approaches to 1 on both sides. So we say that the limit of sine x over x as x approaches to 0 is 1. This is theorem, and we can prove it, but for now it's not needed. Okay, using this limit we can do more limits. For example, the limits of as x approaches to 0 of sine 5x over x, sine 5x. These kinds of limits can be done using this theorem. So let's gonna see how we solve these kinds of limits. The first one, from this one, it is sine 5x instead of x. So if we do both sides, both the numerator and the denominator 5 over 5, then the numerator could be 5 if we multiply both numerator and denominator by 5. So sine 5x over 5x, it looks like sine x over x. If we relate this 5x by, for example, y, then this will be the same. So for these kinds of limits, we're gonna multiply both numerator and denominator by 5, and this 5 can be out from the limit, and the limit of sine 5x over x, 5x will be 1, so 5 times 1 will be 5. For the second case, sine 5x over sine 4x. So let's divide this one by 5x and let's divide this one by 4x. Then, but first, if we divide by x both sides, I mean both numerator and denominator by x, then it would be sine 5x over x and over sine 4x over x. But if we multiply both numerator and denominator by 5, for example, as we did before in question 1, in example 1, so it will looks like 5 sine 5x over 5x. So this 5 cancelled by this 5. So, and here 4 can be cancelled by 4. So this is the same as these limits. Thus, sine 5 times sine 5x over 5x over 4 times sine 4x over 4x. This, the numerator looks like this one. At for example, at question 1, this is the same as that of this numerator. Then from limits law we can do the limits of numerator and then the limits of denominator each, and we can do division operation. So these limits will be 5 times 1, so it is 5 as we did before, and 4 times sine 4x over 4x is 1, so 4 times 1 is 4, so 5 over 4 it will be the last. For question number 3, this question is as x approaches to 2 of sine 2 minus x over 2 plus 3x minus 2x squared. The first thing we're gonna do for limits is checking by substituting if this denominator is undefined, I mean this denominator's value is 0. If it is 0, it means undefined, so we're gonna search some methods to solve it. So let's gonna substitute it 2 plus 3 times 2 is 6 minus 2 times 2 squared is 4, so here will be 8. 2 plus 6 is 8, 8 minus 8 is 0, so this is undefined. So we must search a way to cancel out or to make it most familiar. The first thing we're gonna do is let's this factor out as 2 minus x, so 2 minus x 1 plus 2x. So here we have 2 minus x and 2 minus x. So if we let this one by some variable, so let's say let u will be 2 minus x, so as x approaches to 2, this u will be 2 minus 2, so u will be approaches to 0. So finding this limit as x approaches to 2 is the same as that of substituting the value 2 minus x by u and making u approach to 0. So it will be sine u over 2 minus x will be u, and 1 plus 2 times x, x will be 2 minus u, so 2 minus u. Then it will be using limit law, so finding the limits of each, that means sine u over u, one function, and 1 over 2 times 2 is 4, so 1 plus 4 is 5, 2 minus u is 2u, so this will be minus. This is minus, this is incorrect. Then we're gonna find the limit. This limit is the same as the limits of sine x over x as x approaches to 0, so this will be 1. So 1 times, let's substitute 0, so when we substitute 0, so 1 over 5 it will remain. So we have 1 times 1 over 5, it gives 1 over 5. This is the way how we're gonna find limits using the theorem, limits of sine x over x as x approaches to 0. Let's gonna start the second theorem. The second theorem says the limit of 1 plus 1 over x, the whole power of x as x approaches to plus or minus infinity gives the natural logarithm number e, that means 2.73 something, so it gives e. We did not do its proof, but we will use this theorem to solve problems. The first problem is the limit as x approaches to infinity of 1 plus 5 over 2x the power of x. Here we have a term 5 over 2x in place of 1 over x, so let's gonna say this term as y, and so let's say this term as 1 over x, so 1 over y, so 1 over y equal to 5 over 2x. So finding x will give 5 over 2y. Then let's substitute these terms, that means 1 plus 5 over 2x, 1 plus 5 over 2x will be substituted by 1 over y, so let's substitute 1 over y here, and x will be substituted by 5 over 2y. So this limit is the same as finding 1 plus 1 over y, and 5 over 2y is the same as here y and the whole power 5 over 2. It is the same. So from limit law we can say that finding the limit for inner one and then making the power of 5 over 2. This inner limit will be the same as this theorem, so it will be e the power of 5 over 2. so e the power of 5 over 2. Let's see example 2. Example 2 is x plus 4 over x minus 1, the power of 3x minus 2. So let's divide this numerator by x and also the denominator by x. So this numerator by x will give 1 plus 4 over x, and dividing by x will give here 1 minus 1 over x. The whole power of 3x minus 2, it is unchanged till now. Then we can find the limits of each numerator and denominator separately, and we're gonna make here the power. So here is from limit law. Finding this limit is the same as that of finding the limit of 1 plus 4 over x, the power of 3x means x the power of 3, and minus 2, let's separate the limit here as minus 2. So here is making separation. After that, we can find that the limit of as x approaches to infinity of 1 plus 4x, the power of x, we can make it here x. So this is the same as finding as before. If there is here 4, let's see before, when there is 5 over 2 here, then remember the last answer will be e the power of 5 over 2. So here this 5 is become power, and this is also the power over 2. So if there is a term 4, so it will be e the power of 4. So this will be e the power of 4, and this will be e the power of, here is minus, so e the power of minus 1. So these limits have the value of e the power of 4 and e the power of 1, the whole cubed, and times this one. So the limit of 1 plus 4 over x as x approaches to infinity will be, this one will be 1, and 4 over x will be 0. 0 the power of minus 2 is 0, so it will be 1. But here the limit of as x approaches to infinity of 4 over x, it will not be 0 because 0 the power of x, it means 0 the power of infinity is not 0. But here 4 over x is 0, so 0 the power of minus 2 or any number will be 0. So this will have a value of 1 over 1. So, and multiplying by these values, that means e the power of 4 over e the power of minus 1, the whole cubed times 1, which gives e the power of 15. For those kinds of problem, we have a simple theorem after we see the derivative. It's called L'Hospital's rule. After seeing derivative, we're gonna see what is L'Hospital's rule. Till then, try to remember these limit theorems, and please do this exercise. For now it is enough. If you have question, you can ask on the group. Have a nice time.